What if I told you that a giant SpaceX rocket just slammed into the moon at thousands of miles per hour? It sounds like the plot of a science fiction movie, but according to early reports, a spent Falcon 9 upper stage ended its journey by impacting the moon. The event immediately captured the attention of scientists around the world because it offered a rare opportunity to observe a predicted lunar impact. Researchers had been tracking the rocket's orbit for weeks, calculating exactly where and when it would reach the moon. Unlike Earth, the moon has almost no atmosphere, so nothing could slow the rocket before impact. Instead, it struck the surface at incredible speed, creating a fresh crater and blasting lunar dust high into space. But how did a SpaceX rocket end up on a collision course with the moon? Was this an accident? Or was it simply the inevitable result of orbital mechanics? To understand the answers, we need to go back to the beginning of the mission. Every SpaceX mission begins with a clear objective. The Falcon 9 rocket successfully carried its payload into space, completing the task it was designed for. After releasing the payload, the upper stage had finished its job. Unlike the reusable first stage that often lands safely back on Earth, the upper stage continued its journey through space. For missions that travel far beyond Earth's orbit, safely disposing of the upper stage is much more difficult. Instead of returning to Earth, it remained in space, drifting silently with no active engines, no crew, and no ability to change course. From that point onward, gravity became the only force guiding its future. Although it was no longer useful for the mission, it continued traveling through the vast emptiness of space. Space may appear empty, but it is filled with invisible gravitational forces. Earth's gravity constantly pulls on nearby objects, while the moon and even the sun also influence their paths. These forces may seem weak, but over months they can dramatically change an object's orbit. Astronomers carefully monitored the Falcon 9 upper stage and noticed that its trajectory was slowly changing. Using powerful computer models, they predicted that the rocket would eventually collide with the moon. As additional observations confirmed the calculations, scientists became increasingly confident that the impact was unavoidable. Since the rocket had no fuel left and no engines capable of changing its path, there was nothing anyone could do to prevent the collision. When the predicted day arrived, the Falcon 9 upper stage struck the moon at roughly 8,700 kilometers per hour. Because the moon has almost no atmosphere, the rocket did not burn up or slow down before impact. All of its enormous kinetic energy was released within a fraction of a second. Rocks shattered instantly, clouds of dust exploded across the lunar surface, and material buried beneath the moon for millions of years was blasted into space. Scientists using telescopes searched for evidence of the collision and reported observations consistent with the impact, including debris and light signatures produced by freshly exposed material. Although no human witnessed the collision directly, scientific instruments provided valuable information. Scientists estimate that the impact created a crater about 20 meters wide. While that may seem small compared with the moon's enormous ancient craters, it is extremely valuable for research. Fresh craters allow scientists to compare detailed photographs taken before and after an impact. This helps researchers measure how much material was excavated and how debris spread across the surface. Every new crater also improves computer models used to understand asteroid impacts throughout the solar system. Events like this help scientists prepare for future lunar exploration and improve our understanding of planetary geology. One reason this impact is so important is that the moon preserves its history. Unlike Earth, the moon has almost no atmosphere, no rain, no rivers, and no weather to erase impact scars. Every crater remains visible for millions or even billions of years. The crater created by this rocket could survive far longer than human civilization itself. Future astronauts may one day visit the site and study both the crater and any remaining fragments of the rocket. For scientists, it represents a unique opportunity to examine a fresh impact whose timing and location were predicted in advance. The event also highlights the growing challenge of space debris. Humanity is launching more spacecraft than ever before, and many missions leave behind upper stages and other hardware after completing their work. Scientists and engineers are discussing better ways to dispose of these objects safely. Possible solutions include directing spent rocket stages into controlled disposal orbits, sending them into solar orbit, or planning intentional impacts for scientific research. As space exploration continues to expand, responsible management of spacecraft after their missions end will become increasingly important. The Moon has recorded the history of the solar system for billions of years through countless natural impacts. Now, it also preserves another chapter in humanity's exploration of space. Whether viewed as an accident or a valuable scientific opportunity, this event demonstrates how every mission leaves a lasting legacy. Scientists will continue analyzing the new crater and comparing images from lunar orbiters to learn more about the Moon's surface and the physics of high-speed impacts. As humans prepare to return to the Moon and eventually travel to Mars, lessons from events like this will help shape the future of deep space exploration.